in case anyone's interested in coming to shul, the next 3 Shabbases, we don't have a bar mitzvah. So we're letting up to 40 people come either Friday night or Saturday morning. We've got about 25 people signed up Friday nights and about 15 to 20 on Saturday mornings. It's in the Baruch Sanctuary. So there's plenty of social distancing. You have to wear a mask the entire time. You can come to the Baruch Sanctuary with the clergy. We also have our chapel service that started up again, and that's every day. And they're taking up to 40 people as well.
Are you having 40 people in both congregations?
Yes.
And do you have to register, Brian?
You do have to register. Just you can go to our website. You have to log in. You have to register. If you have any problems, just email me and I'll put you in touch with Jennifer Rosenzweig, who's on this call as well, and we'll help you out. Or just email help@bethyshur.org. And there's daily minyan every day at 7 a.m. and then at 5:30 p.m. And then on Shabbat, you get your choice of 2 services. So as long as everyone agrees to wear masks and keep your social distance, everyone's been great about it. It's been nice to see people, and we've been doing this really since May, but we're able to open up a little bit more right now. And the daily minyan in the morning service just started again yesterday. So it's been nice. It's been nice to see people again.
Hey, Brian, you mentioned wearing a mask. What is the dress code now during this time? Like on Saturday morning, is it a normal coat and tie or?
It's a good question. I've been telling people if there's not a bar mitzvah, just a nice dress shirt and pants is fine. You don't have to wear a coat and tie if there's no bar mitzvah. If you want to, you can, but you certainly don't have to.
And
If
the
there's a
tie is supposed to
bar
match
mitzvah,
them.
the expected is coat and tie?
Yeah. Now, with that said, when we have a bar mitzvah, the only service members can go to is the chapel service, because the bar mitzvahs were allowing just guests of the bar mitzvah to come at this point. But there's still a member-led service, basically a chapel service in the Freeman Levitt. And that's always open for members. All right. Well,
off topic on that, Brian, we watched Aaron Feldman's bar mitzvah last weekend.
Yeah.
And doing the service on the bima, and then having him be at home, being able to switch back and forth like that was really great. And it was just seamless. It really was a nice way to do it for those families that didn't want to be in the sanctuary.
Exactly. It's interesting. We have some families that want more than 40 people, and we have some families who want to do everything from home. And so we got to be available for any family that wants to do their bar mitzvah. We've had some families who postponed their bar mitzvahs until next year. So we've had all kinds of approaches, but luckily we've been able to maintain the B'nai Mitzvah program. And last Shabbat was really nice. He did a good job. He really did.
Yeah, I liked it.
Well, I want to remind everyone, our next 100 Jewish Men's program is a little under a month away, November 18th, a Wednesday night. We're going to be joined by Mayor Andrew Freiberg, who's the mayor of Bel Air. His parents are members of our congregation. Andrew grew up here in Houston. He is serving I believe it's his 3rd term as mayor of Bel Air. He's dealt, a lot of issues with the flooding. Some of you live in Bel Air probably saw the sidewalk issue, stuff going on in the Bel Air Triangle. And through it all, Andrew's really shown a lot of grace and wisdom. And I think he'll have a lot to share, what it's like to be a Jewish mayor of a town like Bel Air, Texas. So that will be next month, Wednesday, November 18th. And so with that, just know, you guys need anything, just reach out to me or the other clergy or Jennifer Rosenzweig. We're always here for you guys. Appreciate everyone tuning in. I'm going to turn it over to Wayne. Wayne Arzt is going to introduce our distinguished presenter this evening.
Good evening, everybody. I'm glad everybody is here. And John, I'm glad you can join us. I am, by way of introduction, I'm Deb Newbeck's friend, and that's how you got a part of our organization through Deb. John, folks, is a member of NASA's program team that is planning the return of astronauts to explore the moon. He's been with NASA for 33 years, and his projects include lunar landing design, lunar landing systems, human Mars mission planning. John has held positions with as Chief Exploration Scientist, NASA's Lunar Surface Systems Lead, Human Mars Study Team Lead, and working on the Altair Lunar Lander Deputy Program Manager and Special Assistant to the Johnson Space Center's Astronaut Office. His career has been defined and devoted to future systems that will allow and send human crews beyond low Earth orbit and return them to the moon and then hopefully to Mars and beyond. So with that, I'm going to have John pick it up from there and discuss his NASA exploration strategy for our team, for our group.
Well, thank you, Wayne. And it's good to get to know you. And I'm sure we're still all shocked by what happened to Deb and her family recently. And we pray for them, of course. So hi, everyone. I don't have a cool background like Mark Newman does that shows the Kemah waterfront behind me. My background looks like it's a small kitchen in a hotel in South Texas, which is where I actually am right now, working down with the SpaceX folks down here in Boca Chica. Very exciting. And what they're doing is part of a bigger effort that NASA has to return people to the moon and eventually go on to Mars. So I wanted to talk just for a few minutes with you today about some of the things that that NASA is up to, and then we'll let you ask some questions a little later. So it would not be a NASA presentation if I didn't have a cool set of PowerPoint slides. So is everybody seeing that? Just give me one yes out there if you're.
You're good.
Okay, thanks. Thanks, Jennifer. Okay, so we're going to talk about NASA's exploration strategy and talk about how it affects the folks in the Houston area. I wanted to start, though, in Israel, because one of the cool things that NASA has let me do over the years is they've loaned me out for a number of years to be the director of International Space University. And a few years ago, we were hosted by Technion in Haifa. And you can see the class of young professionals there. ISU is a school that's all about developing the next leaders in the space industry. So I had the pleasure of spending 3 months in Haifa, and part of that was touring Israel with Buzz Aldrin, who's a good friend of mine. So there we are at the Baha'i Gardens, I guess, in Haifa, and there's Buzz in all his magnificence, talking to the folks there in Israel. The other thing I got to do while I was there was bring NASA astronaut Jessica Meir over, and Jessica is, she's the Israeli people have basically taken her on as their own because her dad is Israeli, and so it was great to have her over there, and she's one of our Jewish astronauts right now. So we had a lot of fun things. David Levy I brought over also, most famous for co-discovering comet Shoemaker-Levy 1, which crashed into Jupiter rather, sorry, a number of years ago. So we brought the whole gang over from the U.S. to basically talk to the folks over in Israel, and we had a great time over there. Okay, so we're going to talk. We're going to bring it back from Israel and head out into space. So it's been way too long since the last astronaut left the surface of the moon and headed back to Earth, and we've basically been stuck in low Earth orbit now since 1972, which is almost unbelievable for those of us who grew up watching Neil and Buzz and the rest of them prance around on the moon. It's unimaginable that it's been that long, and there's only a few moonwalkers left. And in a few more years, they're all getting into they're all about 90 now. And, it's not going to be long before there's not a single person left on this planet who has visited another planet. And we hope to do something about that. So NASA's plan is to take the best of government, the best of commercial industry, the best of our international partners, and put together a plan that gets us out of low Earth orbit and start pushing out towards living around and on the moon and eventually heading to Mars. So, so that's what our vision is. You notice the word commercial is in here quite a bit, and I'll talk about some of the commercial initiatives we have. We live in a very fortunate country where we have individual commercial entities that have capabilities that are equal to or in excess of individual nation states elsewhere. I mean, there's only 3 countries on Earth that can launch humans into orbit, but we have at least one company, SpaceX, that's done it already, and Boeing is right behind. So we're very fortunate that our system of government and our system of commerce allows that to happen. So we're going to keep pushing our commercial partnerships and build coalitions with those partners and industries and other nations to make this program go. So as I go through these slides, I'll put together the pieces of this program that we're putting together. Okay, so obviously we've spent a lot of time in low Earth orbit. The International Space Station is coming up very shortly on its 20th anniversary of housing humans in orbit. So for anyone 20 years of age or younger, those people have never known a day on Earth where there hasn't been someone living in space. And we want to keep it that way. And in fact, I'd love to say, some 20 plus years from now that, the young generation never knew a day where someone wasn't living on the moon or someone hadn't walked on Mars. So the idea is to keep pushing beyond where we've been and to new worlds. Now, I mentioned the International Space Station. The ISS has been amazing in a couple ways. Number one, it's been a great tool for international diplomacy. It got us and the Russians and many other nations to work peacefully together on the largest peacetime technical project ever. The other amazing thing about it is that it's composed of pieces that were made in many different factories here in the US, many different countries around the world, and through the excellent engineering that was put together by all those partners, all those pieces went up at different times, and we put them together and connected them all up, and darn it if they don't all just work and pretty much work perfectly. So it's pretty much a testament to the folks who run the International Space Station program and all the partners that built all the hardware that we were able to do this. It's pretty amazing, and it's been running now, occupied for 20 years, and I don't know if it has another 20 years in it, but it'll be there for a little while, yeah. So some of the the ISS is constantly in need of resupply. You need food, you need experiments that go up and down, you need water, and you need people. And so we've started looking to commercial industries to take some of the cargo to and from the space station. So you can see on this slide the Dragon capsule from SpaceX, the Cygnus from Northrop Grumman, and soon to be launched the Dream Chaser from Sierra Nevada. And those 3 vehicles are our commercial resupply vehicles for the folks living on station. Now, the Russians, of course, still launch their resupply vehicles as well, and the Europeans have a resupply vehicle, and the Japanese as well. But the bulk of the work is done by the American vehicles that you see here, and that's been a great partnership. By doing that, NASA has really been able to save a lot of money because we basically are paying just for transportation services. So somebody like SpaceX, the contract is for them to fly so many tons of supplies to the space station. If they do that successfully, they get paid for it. If something happens to their rocket and those supplies don't get delivered, NASA doesn't pay for it. So all the risk, we transfer the risk over to the commercial providers, and their they're happy about that. Everybody wins. The next step is going to be commercial crew transportation, and we've already taken the first step here. We've had our first commercial crew demo with the SpaceX Dragon capsule on the upper left there a few months ago, and we took 2 crew members, Bob and Doug, to the space station, brought them back a few months later, and that was a very successful mission. Based on what we learned from that mission, we're making a few improvements to the SpaceX capsule, and those should just about be done, and the target date to launch the first regular commercial crew is next month. So sometime in November, the first true, regular flight will take place. That first flight we flew was kind of a test. That the first true revenue flight, I guess you'd call it, starts next month. And then not too far behind, the Boeing Starliner that you see in the background of the big picture there, will start doing the same thing. They'll have a demo flight and then eventually start regular flights. So this is yet another idea about using commercial partners. So whereas NASA used to, buy spacecraft from contractors and then fly them ourselves, or space shuttles for that matter, we're now letting commercial industry do that because they now have matured to the point where they have the technology to do this, and we're grateful that we have those kind of companies. So here's the first crew that's going to go up on the regular crew flight. This is called the Crew 1 mission, and we have I'm going to get everybody's name wrong if I tell you the crew members, but there's 4 obviously, and Soichi from Japan is on the right, so we have an international crew, and we have 2 NASA astronauts on this crew. So they're standing by for everything to be fully prepared for them to take off next month. Okay, so that's low Earth orbit. Now we're going to start pushing beyond. The moon is actually the place I personally want to get people back to. It was, I vividly remember the Apollo missions when I was a kid. I was 9 years old when Neil and Buzz landed on the moon, and it's what got me all excited about working for NASA and flying model rockets and all those kind of things that a 9-year-old does. I've been very fortunate that I've gotten to work with Neil Armstrong and Buzz and most of the other guys who have walked on the moon. So I kind of like the way the circles have closed. And I feel like it's somewhat my duty now to make sure that that there's something for the next generation, that sense of excitement we felt when we landed on the moon for the first time is going to, it's obviously going to come back the next crew we put on the moon. That same excitement about humans going out there and pushing the envelope and touching the unknown. So going back to the moon is very important to me personally, and it's very important to NASA as well. So NASA created what it calls the Artemis program. Artemis in mythology is the twin sister of Apollo, goddess of the moon. And so that fits perfectly. That Apollo program of the 60s and 70s led to the Artemis program of the 2000s. And the Artemis program is a bit more broad than Apollo, where Apollo was really a political program about beating the Russians to the moon and proving that our system of technology and our way of governing was better than the other guys. The Artemis program doesn't have quite as much of a political connection to it. There's still a little bit, but it's really about having capabilities greater than what we had in Apollo. So when we go to the moon, we're going to land on in areas of the moon we couldn't get to in Apollo, and the one we're shooting for first is the South Pole. And I'll explain the South Pole here in a little bit, but the Apollo program was done very fast, very well. But what they did was they created a series of spacecraft that could only get to the equatorial belt of the moon and really only on the front side facing Earth. And so they're very limited by the places they can go. The Artemis program is about getting to the whole moon, to explore it, to get back there and finish the science that was, or continue the science that was done during Apollo. The other main goal of Artemis is to use the moon as a test bed to get ready to go to Mars. And I'll talk a little bit about that as we go on. So here is a famous NASA swoosh chart. So you can see the swoosh coming out of the Earth there. And it, of course, represents time going from left to right. And you can see a couple vehicles. And the first one is Artemis 1. That's our first test of the of our new launch system and new crew vehicle. I'll talk about each of these in a little detail. But it kind of looks like a mini bottle of Coke flying there with some solar panels. And then Artemis 2 will be the first time we put humans on that vehicle and fly them around the moon. And then eventually we're going to get to Artemis 3 at the far right side of this slide, which is the first time we use this new exploration system to actually take crew to the surface. So there's a lot of piece parts in motion, literally here, and I'll talk about each of those as we go. But the vision really doesn't stop there. That's kind of where it starts, getting people back to the moon. In addition to the surface of the moon, we're going to build a small space station, if you will, in lunar orbit called Gateway. And there are good physics reasons for having a waypoint orbiting the moon, just like there's good reasons for having an International Space Station orbiting Earth. And it's going to be key in us getting to Mars. And then along the bottom, you see a lot of things happening on the moon as well. You see rovers and habitats and power systems and things like that, all of which are key to using the moon as a test bed to get to Mars, as well as using the moon to extract some of the resources that will actually help us stay there much cheaper than we could if we had to bring everything with us. Okay, and so one of those keys and one of the reasons we're heading to the South Pole is because of water. Back when we finished the Apollo program, we had no idea that the moon had water on it. In fact, the byline at the time about the moon was that it was a desiccated planet. It was literally free of all water. It was totally dry. Well, then we did an experiment where we crashed a small spacecraft near the South Pole, and we got readings of water in the material that was thrown up. And since then, we've put different spacecraft in orbit around the poles of Mars, especially, and we find that when you look at the poles, you see large concentrations of hydrogen-bearing things, and it could be water, it could be other things, ammonia, I suppose, things like that, but most likely it's water. And we see these in what are called the permanently shadowed regions. So because the moon rotates almost perfectly on its axis with respect to the sun, the shadows near the poles never receive any sunlight. And because of that, they're very, very cold, like a few tens of degrees above absolute zero. So any material that falls into these from comets or other sources is trapped there, and over the billions of years has accumulated. And those are the things that we're seeing. And we think that some of those permanently shadowed craters, permanently shadowed regions near the poles of the moon contain large quantities of water ice and perhaps other things as well. So we want to go and check that out. And the reason we want to check it out is because water is one of those things that you need for almost everything. You need it for the human crews, obviously to drink. You break it down into hydrogen and oxygen. The oxygen is what you breathe. Hydrogen is a rocket fuel. And anything that you could actually find on a planetary surface that you don't have to bring with you does a magical thing. It cuts the rocket equation, which is what moving around in space is all about. It kind of cuts this chain of rocket equations that represents every stage of a rocket, kind of cuts that right in the middle. And if you could do that, the trickle-down effect going all the way back to the amount of mass you have to launch from Earth is astounding. So we're hoping to find water on the south pole of the moon, and we have a few targets identified that we want to go to near the South Pole crater, which is called Shackleton. And that's the subject of a robotic mission that's coming up, as well as investigations that the crew will do as well. So that robotic mission that we're sending to the moon is called Viper. Volatiles, and well, you can see how NASA likes to make acronyms out of things. So I think we chose Viper first, then we tried to figure out something that to do with those letters. And so Viper, the two first words are the most important. Volatiles investigation. And volatiles means water and some of those other things that might be trapped in these lunar cold traps. So this is a rover. It's let's see, it's smaller than a golf cart, but you know, pretty good size. And it's going to trundle down into those permanently shadowed regions, drill down, and actually sample the materials that are in those permanently shadowed craters. It's a very tricky mission because, like I said, those craters are at a few tens of degrees Kelvin, which is incredibly cold, and so you have to actually have a system that can work at 30 or 40 degrees Kelvin, which is which is below the temperature of liquid oxygen, for example, which is 90 degrees Kelvin. So Viper is going to launch in 2023, I believe. We're building that rover right now at the Johnson Space Center, and it's going to be launched to the moon by one of our commercial launch providers. We have a team of small lunar lander contractors who are standing by that when NASA comes up with a payload, we kind of put a little, little notice out, and they each bid on it, and whoever, of course, bids, gives us the best price, gets to fly it. And so there are, so Viper is going to fly on a small lander, and we have other experiments like it that some of these small lunar lander commercial providers are flying to the moon as well. So very exciting. Now, I talked about going back to the moon and the idea that it's linked to resources, it's linked to getting to Mars, but we've actually done a very good job of cataloging what the specific things we want to do on the moon are, and it kind of starts with this kind of list. And the scientists are very good at doing this, at making kind of a prioritized list of science that they want to accomplish on the moon. And similarly, we have technology things we want to accomplish. We want to test different kind of technologies. We have operational things we want to test. How do people work in extended periods of partial gravity, which is what we'll experience when we get to the surface of Mars. So there's a lot of things that we want to do on the moon. We won't be able to do them all in the first mission, or even the second or third. It'll take a few to get through all these, but we've done a good job of cataloging and writing down all the things that we hope to use the moon for. Okay, so we talked generally about going to the moon. Now let's talk to some specifics. What kind of hardware is it going to take to get us there? NASA has in construction right now a new crew capsule that is being designed especially for deep space use. It's called Orion. You've probably heard of it. It looks a lot like the Apollo capsule, except quite a bit bigger. And the first 2 Orion capsules are already at the Kennedy Space Center waiting for flight. The third one is in construction right now, and that will be the one that takes the first woman and next man out to the moon for the first part of their mission as they go down to the surface. The SLS is the Space Launch System. It is a big, powerful rocket. It's more powerful than the Saturn V, and you need that kind of power to push things like the Orion capsule out to the moon and other big payloads that you're going to need for a gateway and lunar landers and things like that. We're doing a lot of work with our brethren at the Kennedy Space Center who take care of exploration ground systems, because it turns out that rockets don't just launch themselves. You need You need a lot of infrastructure down there, and so they are ready to. That they've modernized their infrastructure. They're ready to go, and so so let me show you a little bit about each of those systems. And those are the first three pieces that we'll need to do the Artemis 1 and Artemis 2 mission. So there's the Orion spacecraft. If you squint a little bit, it looks a lot like the Apollo spacecraft. It has a service module behind it. That's a gift from the European Space Agency. So it's an international partnership. And Lockheed Martin is building the vehicle itself. And so here's a comparison of what it sort of looks like in size comparison versus Apollo. So you can see Apollo had kind of a big engine and a long service module and a small capsule on the front. Orion has a much bigger capsule, a smaller service module, and a small engine. So what we've done is we've taken some of the workload that the Apollo command service module did, and we've kind of shifted that to other vehicles. And so the service module has gotten a little smaller on Orion, but the amount of time it could spend in space, the number of crew it can take, all of that is greatly in excess of what the Apollo system could do. The Space Launch System is going to be a great rocket to watch launch. For those of us who never got an opportunity to watch a Saturn V launch, the next best thing, and maybe even the better thing, is when the Space Launch System takes off. So starting next year, we'll see the first launch of the SLS on the Artemis 1 mission. And if you have one chance to get to Florida, to the Kennedy Space Center, to watch a launch, that would be the one I would go to, because it's going to just shake the ground. It's going to be an amazing thing to witness. So here's here's physically what the SLS looks like. It has a few different variants. While it's physically a little smaller than the Saturn V, when you start replacing liquid engines, which is what the Saturn V was, with a few of the solid rocket boosters, you actually get more horsepower, more thrust out of the rocket. So the total performance of the SLS is actually in excess of what the Saturn V was. You can see Saturn V was about 35,000 kilonewtons. That's not a number anybody really uses. 7.9 million pounds of thrust, and SLS 8.8 million pounds of thrust. So that's the stuff that makes your heart beat as it's lifting off. And then at Kennedy, you can see that we have all the facilities to process the rockets, to process the space vehicles, and to launch them. So here's the good news about all those things I was just talking about. They're more than just PowerPoint slides. This is the first Orion vehicle at the Kennedy Space Center, and it is ready to be stacked on the SLS rocket for the first mission next year. In the background, you can actually see a second one. If you kind of follow the lights on the ceiling there, you can see the second one already stacked as well. So good news, these are real. The SLS itself is almost real. We have it on a test stand right now in Mississippi, and in the next few weeks, we're going to perform what's called a green run test, which is literally we're going to light the 4 engines on this and run them for the full duration that they are expected to run for the mission. And then we're going to, once that's satisfied, we're going to take that vehicle. It's going to go on a barge to the Kennedy Space Center, and that's the one that's going to fly the Artemis 1 mission. And there you see Kennedy Space Center. We just repainted the NASA logo and the flag, by the way, on the side of the VAB. It's hard to tell from this view how big that building is, other than that launch tower there that's just rolled out of it, will hold that SLS vehicle on it at 300 plus feet tall. But if you look at that American flag, each stripe of that flag is the width of a lane on a highway. So that red, take one of those red stripes, that's whatever the standard highway lane width is, 11 or 12 feet, something like that. Okay, so So that is all the good news that's going on. That we're getting prepared for that mission. So Artemis 1 is going to be the first, our first chance to test all those systems together: the Orion spacecraft, although it won't have a crew in it, the SLS, and the new launch systems, the Kennedys. So again, if you happen to have a Florida vacation scheduled next year, when this is about to lift off, that's good scheduling on your part. So naturally, after Artemis 1 comes Artemis 2. Artemis 2 is basically the same mission, except now we put crew members on board. And we're going to take the 4 crew members around the backside of the moon, and we're going to take them further out into space than any humans have ever gone. So they will go around the backside of the moon at about 5,500 miles altitude. The Apollo missions went around the moon at about 60 to 100 miles altitude. So we'll be well beyond that, and just kind of touching the sphere of influence of the Earth-Moon gravity system, and that's important for future missions. So we're going to send a crew out and then bring them back and test the whole system with the crew aboard it, coming back at lunar return speeds. And so that's going to be a very, very big mission, because that's going to be the first time humans have left low Earth orbit since 1972. So that mission is only a couple of years out. Then, of course, there's Artemis 3. Artemis 3 is about returning crews to the surface of the moon. And our first mission will take the crews down, for a crew of 2, for 6.5 days on the lunar surface. They'll conduct probably 4 different moonwalks, and possibly a 5th, and bring samples home. And it will be the first time that that people have ever gone to the south pole of the moon. And so that will be a very special mission. Now, to get to the surface of the moon, you need more than an Orion and an SLS rocket. You need a lander. And so back in earlier this year, NASA put out a solicitation for commercial companies to provide lunar landers. So just like the commercial cargo to space station, commercial crew to ISS, we're using that same sort of way of buying services, and we're going to buy lunar lander services for our crews to go to the surface. And what we're buying specifically is an elevator ride. We'll take the crew out to lunar orbit. They'll transfer to a lander that belongs to a company. That lander will take them down to the lunar surface. They'll do their surface mission. The lander will bring them back to the orbiting Orion spacecraft or to the gateway, and then we'll come home. And at that point, we'll pay the commercial contractor for that ride. And so we're using the same kind of commercial services procurement idea that we have for some of these other things I've talked about. And my feeling is that's kind of going to be the way that things go in the future. That since we have such capable companies, which include a lot of ex-NASA people, by the way, that's kind of the way NASA will buy services in the future. We won't do too much in-house unless it's really, really cutting edge, where nobody else has that expertise. If it's something that's kind of building a spacecraft, and there are a number of companies that can do that. So the commercial contracts are going to be important, and the commercial lander one is particularly interesting. So back in April, we awarded 3 small contracts to get 3 companies started. The 3 companies were Blue Origin, or the Blue Team, as it's called, which includes Lockheed Martin, Northrop Grumman, Draper, and Blue Origin. Dynetics, which is a smaller company out of Huntsville, and SpaceX, which is based in Hawthorne, California, but they're building this vehicle down here in Boca Chica, Texas, which is where I am right now, by the way, working with them. And so you can see 3 very different ways to build a lander. The Blue Origin one is a 3-stage lander, kind of a classic way of splitting the mission up into pieces. The Dynetics lander is horizontal, uses drop tanks on the side, so we would turn that a two-stage lander. And SpaceX is one big rocket with lots of fuel, lots of tanks in it, and that's a single-stage solution. So three very different companies, three very different solutions, and by about spring of next year, we will down select to one or two of these to actually start building the actual lander. Now, so that will take us to the surface for the first time as part of the Artemis 3 mission. The next step after that is what we call the Artemis Base Camp. So now once we have this transportation system that can take astronauts to and from the surface of the moon, we'll also have similar capabilities to land cargo. So you can see a cargo lander in the back right of this picture. And so if you could get crew to the surface, you could get cargo to the surface. That's the main transportation capabilities you need to start building something permanent. And we've named that the Artemis Base Camp. And right now it's going to be located somewhere near the South Pole to take advantage of the resources that are there and as well as the great science that you could do. And one of the key tenets in the base camp is to have a sustainable program of exploration, to sustain those surface activities so that they're not just 6 or 7 day one-off kind of missions, so that we can put people there for longer and longer periods of time, and eventually establish a more permanent kind of presence there. So sustainability is very key to the NASA lexicon. I want to give you an idea of the size of the South Pole area. You can see the kind of an outline of Washington, D.C. here, and there's a crater kind of below it. That crater is about 20 miles in diameter, which if I had been smart, I would have superimposed Loop 610 right over it, because it's exactly the size of Loop 610. And right up here about the 10 o'clock or 10:30 position, right on the rim of the crater, is the exact lunar South Pole. And so these regions around the lunar South Pole are the areas we're interested in, and you can see that there's many that are in sunlight, and there are deep shadows in others, including the entirety of Shackleton crater, and those are the permanently shadowed regions we talk about. Of course, we'll have new spacesuits. The suits we used in Apollo were made barely to work for the 3 days that the crews were on the moon, and we know there was some trouble they had even like on the third EVA trying to get them to seal and the zippers to work. And so we're working on new and better spacesuits that have better mobility, that will actually let an astronaut kneel down. You couldn't do that in the old Apollo suit. So we'll have new spacesuits, although on the outside they'll probably look about the same because they're all covered with the white micrometeorite garment. We're going to have new rovers, just like we are going to the commercial world for landers. We're going to also go to the commercial industry to build the next lunar rover. And of course, there's lots of companies here in this country who build vehicles for all of us, and they are chomping at the bit to build one that will drive on the moon. So we're going to do that. And then eventually we'll have pressurized rovers, sort of the large SUV of the moon, if you will. And NASA has some concepts for those. You might have seen some of those in pictures, or we even had our pressurized rover in a presidential inauguration parade. And some of our international partners have submitted designs to us, and this is JAXA, that's the Japanese Space Agency, in partnership with Toyota, have designed this rover, and they are very interested in offering that to us as part of the Artemis Base Camp partnership. So we have great opportunities coming up. The other thing you need on the surface for longer habitation is the habitation unit itself. And while I don't show any here, it's mainly interior shots. We actually have a number of contractors who are building habitation mock-ups for us now in preparation for what will likely be a commercial habitat procurement at some point in the future. So you can see a bunch of our astronauts here looking at some of these HAB mock-ups that are at various contractor facilities around the country. And then there's Gateway. I talked a little bit about that, but Gateway is that small space station in lunar orbit. It's a place to stage a lunar mission from. It's a great place to stage a Mars mission from. And so it gives you that. So rather than having to bring, you know, a node with you, much like we did in Apollo, where you left something in orbit and then the crew went down to the surface, came back, the Gateway will be a node of sorts that's always in orbit that's available to you. So the first pieces of the Gateway will also be launching very shortly. We have contracts out on all those, and those pieces are being worked on. So it's very exciting. We have a lot of piece parts in motion right now, and a lot of hardware being constructed. And the next 3 or 4 years is going to be a very exciting time around the agency. So I want to finish just about talking about Mars, because I've talked about the connections with, between the moon and Mars, but we really, you know, have to keep stating this, that we're not going to the moon just for the moon's sake. There is a lot of great science to do, and we will certainly do that. But a lot of the things we're going to be doing on the moon is testing the piece parts, the elements, the technologies, the operations that we need to get to Mars. And we've been talking about going to Mars for a long time, and it's always been 20 years out. Well, this year, NASA finally put a date on a Mars mission, 2039. So it's only 19 years out now. So we think that that may be a sign that we're making progress. And I like this chart when someone made it up, bots before boots, and this basically just shows how the robots that we have either on Mars or on their way, and that last golf carty looking rover there is Mars 2020. That's on its way to Mars right now. It will land in February. Those are the precursors for getting ready for humans to go. And so there's a lot that the robotic missions have taught us, and because of that, we're going to be very well prepared when it's time to send humans to Mars. Okay, and here's just a little kind of what you can do in orbit, what you can do on the lunar surface that gets you ready for Mars. So there's lots of things you could do at either the space station or at the Gateway in orbit to get you ready. Things like refueling, learning to live a long period of time in zero gravity, because your transit out to Mars will be somewhere on the order of 8 or 9 months. And then when you get to the lunar surface, we'll be testing the spacesuits, we'll be testing rovers, we'll be testing our radiation protection and our robots and lots of other things to get us ready as well. And so here it is all in a bunch of pictures. These are all the things that you need for a human Mars mission. And notice a lot of them are pictures of things that are happening on the moon, and that's quite by design. That, you know, things like rovers and spacesuits you will first test on the moon before taking them to Mars. But a lot of other things like Mars entry, descent, landing, which I don't have time to get into. Mars has an atmosphere that's just thick enough to be a problem, but not thick enough to really help slow you down much. There's more technologies that we're going to have to develop for Mars as well. Okay, and so finally, my get off the stage slide is that there's a lot of folks at NASA like me who've been working our hardest to try to get us ready to go back to the moon and onto Mars. And it's all the cylinders seem to have clicked into place in the last year or two, and we're very happy about that. And so we're excited about as a team, as one big NASA team and one big NASA plus our contractor and commercial partner teams, getting ready to go back to the moon in the next couple of years. So it's going to be a heck of a next 3 or 4 years. So hang on tight. So with that, I'll open it to questions. Thank you.
Well, John, I can't thank you enough. This is quite a presentation. It gave us a lot to think about and a lot to be excited about, whether we live in Houston or wherever we live. But it's good to see that there's a lot of great plans in motion. So I'm going to open up the floor to questions. I promised everyone we'd be done by 8, but if we go a few minutes after, that's okay too. I want to make sure that if people have questions, they have an opportunity to ask. You can, probably the best way is to write them in the chat room. I already see one question. If you just go to the chat room, you can type in a question and I'll make sure to get to it. So the first question is from Ron Bronfeld. And John, he asks, is there going to be any relationship between NASA and the new Space Force?
Well, a good question. Yeah, there already is, actually. So the Space Force is essentially made up of components that used to be part of the Air Force, and NASA had a relationship with, parts of the Air Force, from a long time ago. So there's always been a connection between NASA and the Department of Defense. It's not. We try to actually make the delineation very deliberate. That there's a civilian side of the space house, there's a military side of the space house, and the only time we really bring those together is where we need to really share information or share technology. So one example is that NASA has an Office of Planetary Defense. Now, sounds cool, but what it means is we're going to be on the lookout for any of those, rogue asteroids coming at the planet, and if we see any of them, we're going to call up the Space Force and tell them about it. And so it's NASA's responsibility to basically, look for stuff, bad stuff. It is the Space Force's responsibility to do something about it. And so in military language, they would deliver a physics package to take care of that.
Very interesting. Let's hope it doesn't come to that.
Yes.
That's good to know. Okay, let me ask you another question. I've got a few other questions here. John Fywell is asking, when did you say that we plan to return to the moon with a manned mission?
Okay, that's right. I probably didn't say the exact date. So the date we're working towards right now is the end of the year 2024, and you may notice that is only 4 years off. That was a challenge that the vice president gave us about a year and a half ago. To get the first woman and next man to the surface of the moon by the year 2024, and that is the date we're shooting for. Now, COVID has affected us a little bit, so we'll see how that plays out. Budgets affect us a little bit. If we don't quite get all the money we need to build a lunar lander, for example, that may push the date a little bit. But right now, we are sprinting towards 2024 unless told otherwise.
So good. Okay, got it. Eddie is asking, why do we want to go to Mars?
Because it's next. No, that's kind of a shorthand answer that I heard once on a television show. Well, and that was The West Wing, by the way. So why do we want to go to Mars? Well, there's actually no one good reason to go back to the moon or go to Mars for that matter. But when you add up all the reasons, it's pretty compelling. So Mars is the most Earth-like planet out there, except something happened at Mars that caused it to lose its atmosphere, to lose all the water on the planet, and become a dry, dusty desert, basically. And so there's some comparative planetology we'd really like to understand on Mars, on how a planet that's so much like Earth eventually became that way. The ultimate goal, though, on Mars is to see if there's life there. That's one of those giant questions, that mankind has always, asked himself: are we alone in the universe? And we just happen to have a planet that's 60 million miles away that may have had life at some point, and we'd sure like to figure that out. And so I think there's some very compelling science questions about Mars which is why we want to go there and find those out.
All right. Lou Dorfin is asking, do you think there's enough long-term political will to provide financial support for a 20 to 50-year program?
So let's see. I'll take off my NASA badge for a second. The long-term political will is actually the biggest challenge in space exploration. We were very fortunate during the Apollo program that after President Kennedy made his proclamation, that presidents that followed continued his his zeal to go to the moon. Now, of course, his go to the moon before this decade is out had a lot of other political undertones in it. It wasn't just for science, but the presidents that followed him understood those and kept those going until we got to President Nixon, and then he decided to cancel the last 3 Apollo missions and start the space shuttle program instead, which was another good initiative in retrospect. But in order to do something like going back to the moon or getting to Mars, it will require sustained commitment across multiple administrations, and we have not seen that. We haven't seen that in the last 20 years. We've seen as administrations change, their direction to NASA changes with them, and that's very disappointing because going back to the moon, going to Mars is a lot like building a cathedral. And you can't go for 4 or 8 years laying down the stones, the first couple courses of stones of the cathedral, and then have a new person come along and say, no, I don't want that kind of cathedral. I want something else, and kick over all your stones. You need a sustained commitment over a long time to build a cathedral, and that's kind of what we're trying to do.
Well, no doubt about that. Okay, next question is, have you seen a way, Dell's asking, with Viper operating in complete shadow, what will be its power source?
So Viper will operate in a complete shadow. While it's down in the permanently shadowed regions, it'll be running off batteries. It has solar arrays, if you see any of the pictures, so it can only operate down in the permanently shadowed regions for a certain amount of time while its batteries are fully charged, and then it eventually has to retreat out of the shadows and back into the sunlight. Marty, I have seen a way, and I liked it very much, and I just heard today that they canceled the 2nd season, so they're not. So Netflix is not reviewing it.
Did it seem realistic to you?
Yes and no. I mean, it was a character drama. It was about an astronaut who's having, kind of all these conflicts about leaving her kids and going to Mars. So it's more of a character-driven thing than a science fiction series. But I'm still sad to see it go.
Well, maybe a reality show in a few years can bring a show about Mars back.
I would actually rather do a real show about Mars.
Yeah, exactly. So Bill's asking how much perhaps percentage does NASA save with the use of commercial companies versus NASA?
Well, that's a good question. So let's take for example, commercial cargo. NASA never built a commercial cargo vehicle of its own, except maybe the shuttle, right? Because we were taking cargo to the station using the shuttle, and depending on who you ask, a shuttle flight was anywhere between a couple $100 million and $1 billion a shot. And for the commercial cargo now that we're sending up via SpaceX and some of the other companies, those flights are in the tens of millions of dollars. So I think we're saving an incredible amount of money by using the commercial providers.
Similarly, I'll skip one question and come back to it, but Jerry's asking, Elon Musk lately stated he wanted to go to Mars in 3 years. Is he on a different timetable than NASA?
Elon's on a different lot of things from NASA. And by the way, he's here in town. I almost ran into him today. No, so Elon's a visionary, right? And he's not afraid to make big proclamations where he puts out time challenges that seem unreasonable, and I don't think he's hit one yet. But he doesn't care because it gets people excited, and it's actually good for the space business what he does. He wants to go to Mars in 3 years. I'll be happy if his vehicle that he's building down the road here is ready to take us to the moon in 3 years. I know going to Mars is his ultimate goal, and just like NASA testing things on the moon as a test bed for Mars, Elon sees his big shiny, silver lander on the moon as the test unit for the same big shiny stainless steel lander that's going to land on Mars a year or two later. So I think he has the same mindset that used the moon as a test bed for Mars, he's not afraid to throw very challenging dates out there. And NASA, we have to be a little better about that because we have to answer to Congress. Elon, doesn't really have to do that. It's a privately held company. I don't even think he has to answer to shareholders.
Right. He can answer to whoever he wants. Similar to question to Mars, can we go to other planets? Is that theoretically feasible?
Yeah, it is actually. And one of the jobs I have is to kind of help NASA with, looking to the future. So we've been talking about Mars for so long that people have forgot that there's actually things other than Mars out there. And right now, I'm working on a mission design to take humans to the giant asteroid or dwarf planet Ceres, which is out beyond Mars. But it turns out you could use a great deal of the Mars transportation infrastructure to take crews there. So there are places to go beyond Mars. The biggest challenge we have is propulsion. And this is a challenge I give to lots of students that I talk to. Right now, with the types of propulsion systems that we have available to us, chemical propulsion, electric propulsion, and even nuclear propulsion, we as a species are stuck in the inner solar system. We cannot really get much past Mars just because the types of efficiencies that we can get out of those propulsion systems won't allow us to travel beyond that distance in any reasonable amount of time. So what I challenge students, especially college students in aerospace, is that if they want to change the course of humanity and win a Nobel Prize in the process, figure out the next big leap of physics in propulsion. Because right now we've pushed chemical propulsion and things like that as far as we can, and we're stuck in the inner solar system as a species unless we come up with something new.
I guess Star Wars and Star Trek are just a fantasy for now.
Well, warp drive, we have people at NASA working on warp drive. A good friend of mine had a lab where he had a test set up, and he said, yeah, one of these days I'm going to turn this on and see if we can make a warp bubble. And I said, well, let me know when you're going to do that so that I will be far, far away from there, because you're either going to, 1, win a Nobel Prize for that, or 2, create a small black hole where your lab used to be.
So, John, any desire to put a super Hubble telescope on the moon or Mars?
We will have a super Hubble telescope when we launch the James Webb telescope, hopefully in the next year or 2. I'm most excited actually about using the far side of the moon, the side of the moon that never looks at Earth, to put a big radio telescope out there and do radio astronomy, because that is a very unique sort of radio quiet zone. It's entirely shielded from all the radio noise coming from the Earth and our satellites, and it can look out into deep space uninterrupted. So I'm personally more excited about radio astronomy than Hubble kind of visible light astronomy.
John, last question. How are the astronauts to survive in the very low temperatures at the lunar South Pole?
Well, it turns out that the very low temperatures are, really in the shadows. And even in Apollo, the astronauts would report if they were standing in the shadow of the lunar module that they could feel the cold through their suits. Now the suits would adjust. The suits have heaters and water going through them to either cool them or warm them. And so we would our spacesuits would be designed for those kind of temperatures. But the temperatures we're going to see aren't that different than what we saw during the Apollo missions. I think what we'll see is many more areas with very deep shadows because we're near the poles. The sun will always be just a couple degrees above the horizon. And so you'll have a lot of long shadows, a lot of very deep shadows. And so so the spacesuits are going to have to take care of the cooling while you're standing in the sunlight. And then when you go into a shadowed area, they switch over to heating. So just like your house does.
Well, John, that's the end of our questions. Any closing thoughts or anything at all you want to share with us?
No, thank you all for giving me this opportunity to spend a little bit of the evening with you. Like I said, I'm down here in Boca Chica, Texas this week, and Elon is here with his big rockets, and they're doing amazing things here in time frames that just are mind-boggling. So check them out online if you want to have some fun. What's SpaceX doing in Boca Chica, Texas, and it'll give you an idea of what American industry can do.
Well, it's nice to know that Texas is still in the forefront of space exploration, and we thank you, John, and know you always have a place to come, Beth Yeshurun. We hope to see you again, and stay safe, and we appreciate you spending time with us tonight.
All right. Torah, thank you very much.
Everyone have a good evening, and be safe, everyone.
Okay.
Be well.
Thanks, guys.